Let's define what we mean by a dependency. There are several types of dependencies: on a framework, on third-party libs, external systems like file system, database, or any system resource, and so on. Dependency on a custom type built on top of the .NET framework. In this section, the most important type of dependencies for us is the dependencies on custom types which are developed by us. For example, here on the slide, the person class depends on person repository class. Person can't provide its features without relying on the person repository class. The person repository is a low-level class which interoperates with a database, while the person is the high-level domain object. So, in this particular case, a high-level object depends on a low-level object. Such a case is aligned with how beginners build software traditionally. This is a high-level view on a classic application with 3 tiers. On the top, we have a user interface. A user interface calls API of objects which implement business logic. Objects which implement business logic call the API of low-level infrastructural objects which implement interoperation with a database, external web service, and so on. What's wrong with the relationships between layers on this diagram? Do you know what it is? The problem is that high-level objects of the domain layer directly depend on low-level objects of the infrastructural layer. The lamp is soldered to the socket like a vise. What would you do if a requirement to change the database management system comes into play? It's hard as hell to replace a dependency if there is a tight coupling between the dependencies. The most frequently changing parts reside on boundaries of a system. User interface and DB-related stuff are irrelevant from the domain perspective. So, the domain logic should be independent of irrelevant things. To fix the problem, we need to revert the dependency which points towards the infrastructural layer. On this example, I'll show you how we can decouple one abstraction from another. A fundamental theorem of software engineering states that we can solve any problem by introducing an extra level of indirection. So let's do exactly that to decouple person from the repository. Here's the slide which reflects the changes made by simple refactoring. We often refer to such interfaces as to seams. These seams allow us to inject any dependency we want, which of course implements that interface. This is a simple yet powerful technique to invert the dependencies, achieving low coupling between components. Another interesting aspect concerns runtime and compile time dependencies. Look at the diagram. Here we have a module A that calls function f on module B through the interface. When we use polymorphism creating an interface, inserting it between module A and module B, we end up with that module A has a runtime dependency on B, but it doesn't have a compile dependency on it. We can compile just module A if we want to, without recompilation of module B. In languages like C++, it helps to significantly reduce the amount of compilation time. That was the basics of what the dependencies are. A logical question which comes to mind concerns what dependencies should we abstract away? And to answer this question, the first thing we need to do is to realize that all the dependencies can be divided into 2 camps, volatile and stable dependencies. Let's define volatile, or in another word, unstable dependencies. According to Mark Simon, a dependency should be considered volatile if any of the following criteria is true. The dependency itself depends on the environment, forcing the caller to set up that environment. A classic example would be a dependency on a database, or any types that imply interoperation with a database. Any other external systems like web servers also fall into this category. The dependency doesn't yet exist and is still under development. This is a regular deal when we want to write code which, among other things, interoperate with an object inexistent at this point. We don't want to wait that object to be written, so we just introduce a sim which reflects the API of that object and make calls through that sim. The dependency which is not installed on all machines of developers. And the dependency has a non-deterministic behavior. It can depend on datetime now, random numbers generation, and similar unstable by their nature things. In general, we can define stable dependencies as dependencies that are not volatile. It may sound odd, but it's quite simple and useful, so we will stick with that definition. Volatile dependencies are those which we want to abstract away by introducing levels of indirection. Since they are unstable, we at least need to have a way to replace them by test doubles in unit tests. Otherwise, we may end up with an untestable application. Remember that you can't treat an application testable until its design allows to write unit tests. If an application allows only integration tests, it should be considered untestable.